Finding the general rule or nth term of a sequence. This lesson helps us formulate a general pattern formula or a general rule for every sequences that is given. Like for the sequence 5, 10, 15, 20, 25, and so on, we can denote the terms as follows. A1 or the first term is 5, the second term is 10, the third term is 15, the fourth term is 20, and the fifth term is 25. Its general rule is an is equal to 5n. Since 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. So that general rule there is only for the sequence 5, 10, 15, 20, and 25. Now the question is, how can we find the general rule and what are the ways to find it? There are two ways in finding the general rule of a sequence. First method is through inspection, and the second is using algebraic method. And we have two formats. For linear, we will follow a sub n is equal to a times n plus b, or an plus b. And if it is quadratic, we'll follow the format a sub n is equal to an squared plus bn plus c. Now we will try the first method, which is using inspection. Example 1. Find the general rule or nth term of sequence 1, 4, 9, 16, and 25. So the first thing that you're going to do here is to count the elements or the number of terms present in the given question. So here we have 5 terms. So we are just going to write the number of terms using the letter n or variable n. So we have 1, 2, 3, 4, and 5. Next is write an, which is its corresponding term. So here the first term is 1. The second term is 4, third term is 9, and then fourth term is 16. Fifth term is 25. After that, establish the connection from n up to an. So inspection is just using your detective instinct, establishing the connection from one thing to the other, and then formulate a general pattern from it. So here, as you have observed, the connection from n to an is that our number of terms, if it is squared, we will have the answer for an. So since our first number here for n is 1, 1 squared is actually equal to 1, or 1 times 1 is 1. If we try to square the second number of n's, which is 2, so we have 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. And 5 squared is equal to 25. So take note that those numbers, 1, 4, 9, 16, and 25, are squares of our n. So from it, we can deduce that the an, or the general rule here, is for whatever number of n it is, all you have to do is to square that number. So for our general rule, we have an is equal to n squared. That's it. Alright, let's try another example using inspection. So example 2, what is the nth term of the sequence 2, 3, 4, 5, and so on and so forth? So again, the first thing that you're going to do is to count the number of terms. So we have, from the given item, we have 4 terms. So you'll just write 1, 2, 3, and 4 for n. Next would be its corresponding term. So the first term is 2, the second term is 3, the third term is 4, and the fourth term is 5. From there, we are going to look for the connection from n to a sub n. So take note here that from our first value of n, which is 1, up to 4, its increase to become a sub n is just plus 1. Diba? Nadadagdagan lang ng 1 ang ating n para maging an. So if you try to write it down, we'll have from the first one, 1 plus 1 is just 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So, nadadagdagan lang ng 1 ang bawat n para maging an. From there, we can establish the general rule. So, if it is n or any number, our general rule is just n plus 1. So any number added to 1. So in writing, we will have a sub n is equal to n plus 1. And that is our general rule. Okay, example 3. What is the nth term of the sequence 1, 3, 5, 7, and so on? Same with inspection, we are going to count the number of terms that is given. So we have here 4 terms. So our n would be 1, 2, 3, and 4. And then its corresponding term, which is a sub n, which is 1, 3, 5, and 7. Now, we are going to establish the connection from one term to the next term if it has a common increase or decrease. So here we can observe that from 1 up to 3 up to 5 up to 7, its rate of increase is plus 2. Okay, so we can follow the format which is linear for algebraic method only if we have the same number or constant rate of increase or decrease. So that would be equal. So for this number, equal siya. Now we will have a sub n is equal to a times n plus b as our format. So if it is not equal, we will follow the quadratic format for algebraic method. Okay, next is we're going to select a pair from our n and a sub n. Any pair will do, but I suggest that you would go with the smallest pair so that it would be easier for simplification purposes. So if you are going to select the first pair, which is 1 and 1, you just substitute it from our main format for linear algebraic method. So that is a sub n is equal to a times n plus b. Our values are just 1 and 1. So we have 1 is equal to a times 1 plus b. And then simplify, multiply 1 and a. So we have 1 is equal to a plus b. And then you just swap since it is an equation. So 1 is equal to a plus b is just the same as a plus b is equal to 1. And then mark it as equation number 1. Next, find another pair or select another pair from our established n and an. So we are going to have 2 and 3 as our pair. So, okay, take note and reminders also. Please substitute the right value. So if it is a sub n, we will use either 1, 3, 5, and 7, the color blue. If it is n only, then we will use the red ones, which is 1, 2, 3, and 4. So now we have the second pair, which is 2 and 3. So our an is 3, our n is 2. So you just substitute the values. So we have 3 is equal to a times 2 plus b. And then multiply a times 2 is just 2a. So we have 3 is equal to 2a plus b. And then, since it is an equation, 3 is equal to 2a plus b is just the same as 2a plus b is equal to 3. So that would be our equation number 2. We need 2 equations to perform our next step, which is the elimination method. So we are going to subtract equation 2 minus equation 1. You just write the obtained equation 2, so that would be 2a plus b is equal to 3. And then the equation 1, which is a plus b, which is equal to 1. And then subtract. So as we eliminate this, we can clearly see that the variable that will be eliminated is b, since b minus b is 0. So let's proceed to the next variable. We have a. We have here 2a minus a is a, or 1a. So, but you can just write 1a or a. It's just the same anyway. So a is just equal to 3 minus 1 is 2. So there we got the first value of our variable. Okay, so a is equal to 2. And then use that value to obtain b. Okay, so we can select from any equation. You can use equation 1 or equation 2 just to solve for b. So if we use equation 1, we'll have a plus b, which is equal to 1. Substitute the number that we have obtained earlier for a, which is 2. So we have here 2 plus b is equal to 1. And then solve for b. Transpose, we have 1 minus 2. So 1 minus 2 is negative 1. And that negative 1 is the value of our b. So from there, we have the value of a, which is 2, and the value of b, which is negative 1. Substitute the two values in our general rule. This would be our last step. So our a is 2, write it down there, and then b is negative 1. So we have minus 1. Thus, our general rule is a sub n is equal to 2n minus 1. Another example for algebraic method. Still linear algebraic method. So example 4, what is the general rule of the sequence 3, 6, 9, 12, and so on? Again, identify the number of terms. We have 4 terms above, so n is 1, 2, 3, and 4. Its corresponding terms, we have 3, 6, 9, and 12. So as we establish the connection from one term to the next term, note that we have an increase of 3, and again they are equal right away. So we have to use the first format, which is a sub n, which is equal to a times n plus b, or a n plus b. From there, we are going to formulate equation 1 and 2. So find the pair from our n and a n. So the first pair that we're going to have is 1 and 3. 3 is for a n and 1 is for n. So we have 3 is equal to a times 1 plus b. And then simplify. 1 times a, or a times 1, is just a. So our next step would be 3 is equal to a plus b. 3 is equal to a plus b is just the same as a plus b, which is equal to 3, based on our properties of equality. Alright, so that would be our equation 1. Next would be finding another pair of n and a sub n. So let us try 2 and 6. So here, 6 is the value of our a sub n, and 2 is the value of our n. So we have 6 is equal to a times 2 plus b. Multiply or simplify. A times 2 is just 2a. So we have 6 is equal to 2a plus b. And then swap. Property of equality. So we have 2a plus b is equal to 6, and that is our equation 2. Now we have two equations. We're going to subtract equation 2 minus equation 1 for elimination method. So here, as we subtract, you just write the equation 2. 2a plus b is equal to 6. And then equation 1, a plus b equals 3. And then eliminate b, because b minus b is 0. 2a minus a is a, and 6 minus 3 is 3. It rhymes. Okay, so the value of a is equal to 3. Next, substitution. Since we have obtained the value of a, which is 3, use it in our either equation 1 or equation 2. So here in this example, I particularly used equation 1. So we have a plus b is equal to 3. The value of a that we have obtained earlier, which is 3, you just substitute it from our equation 1. So that would be 3 plus b is equal to 3. And then solve for b. So we have b is equal to 3 minus 3, which is 0. And there we have our value of a, which is 3, our value of b, which is 0. And then you just use the general rule for algebraic method, which is linear. And then we have a sub n is equal to 3n plus 0. And since the value of b here is 0, you can use we can just disregard that one. So our final answer would be a sub n is equal to 3n. Let us try to answer example 4 using inspection if we can establish the same answer with the one that is being solved using algebraic method. Okay, so again, for inspection, we are going to write the number of terms. So we have 4 terms, 1, 2, 3, and 4 is the value of our n. And then our a sub n, our first term is 3, second term is 6, third term is 9, and fourth term is 12. So using inspection, take note that we are going to establish the pattern from n up to an. So here we can see that it is each and every term is a multiple of 3, or we can find an by multiplying the number of term times 3. So we have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. So if we have n, we have 3 times n, and that is just 3n. So the general rule is a sub n is equal to 3n. And again, if we are going to look at the previous one, which is using algebraic method, which is linear, it has the same answer. But the method which is inspection has much more easier solution than the algebraic one. Next is example 5. Give the general term of the sequence 5, 10, 17, and 26. Now before we proceed, I want you to see that this sequence here, just one look at it, it has no common increase or decrease. From 5 to 10 to 17 to 26, it has different numbers that are being added in between terms. So here we have still algebraic method, but this time it's quadratic, okay? Now, identify the number of terms. Since we have 4 terms here, so we have n is 1, 2, 3, and 4. And then our a sub n, we have 5, 10, 17, and 26. So, write a sub n differently in a scratch paper or any piece of paper. And then first establish the connection between terms. So, we have here for the first one, from 5 to 10, it is added by 5. From 10 to 17, it's added by 7. And from 17 to 26, it's added by 9. And then, for that 5, 7, and 9 there is the first level of increase. For the next one, okay, try to see if in the second level, it has an equal or the same rate of increase. So we have here 5, 7, and 9. So its rate of increase is plus 2. In other words, we can use the quadratic format, and that is a sub n is equal to an squared plus bn plus c. The same with linear, we are going to select a pair, a partner from n and a sub n, wherein we will create equation 1 and equation 2. But this time for quadratic, we will increase it with the third pair, or we will select 3 pairs, in other words, and create 3 different equations as well. So we will select first 1 and 5. That's our first pair there. And here we have our an is 5, our n is 1. So from the general pattern, we have a sub n is equal to an squared plus bn plus c. So we have 5 is equal to a1 squared plus b times 1 plus c. And then simplify. So here 1 squared is just 1. And then b times 1 is just b. And then for our second level, that is just 5 is equal to a times 1 plus b plus c. And then next is, we're just going to multiply a times 1. So a times 1 is a. So we have here 5 is equal to a plus b plus c. That is our equation 1 there. Next, for the second pair, we'll have 2 and 10. So again, the same, substitute for the right value. Ang a sub n is, our a sub n is 10, our n is 2. So again, be careful with that. If you are going to interchange this, the answer would not be correct. Okay? So our a sub n is 10. So we have 10 is equal to a times 2 squared plus b times 2 plus c. And then we have 10 is equal to 2 squared is just 4. So we have a times 4 plus 2b plus c. And then next we have to multiply a times 4. A multiplied to 4 is just 4a. So we have 10 is equal to 4a plus 2b plus c, and that would be our equation number 2. Next, our third pair is 3 and 17. And that would be our 17, that would be the value of our a sub n. So that is 17 is equal to a times 3 squared plus b times 3 plus c. And then just simplify. 3 squared or 3 times 3 is just 9. And then b times 3 is 3b. And then multiply a times 9 or a times 9. So we have 9a. Thus, our equation 3 is 17 is equal to 9a plus 3b plus c. And then we write that equation, the variables on the left side of the equation and the constant number on the right side of the equation. So we will tally all the equations here. So the first one is a plus b plus c is equal to 5. The second one is 4a plus 2b plus c is equal to 10. And the third equation is 9a plus 3b plus c is equal to 17. So from the first, second, and third equation, we will have elimination method. So the first elimination, we are going to subtract equation 2 minus equation 1. So equation 2, 4a plus 2b plus c is equal to 10. And then equation 1 is a plus b plus c is equal to 5. So here we can see that the variable that can be eliminated using subtraction is c, because c minus c is 0. So here we'll just subtract the rest. So we have 4a minus a is 3a, 2b minus b is b, 10 minus 5 is 5. So our answer would be 3a plus b is equal to 5. Mark it as our equation 4. Next, to eliminate, we will subtract equation 3 minus equation 2. Here, again, the variable that will be eliminated is c, because c minus c is 0. So our equation 3 is 9a plus 3b plus c is equal to 17. Our second equation is 4a plus 2b plus c is equal to 10. And then subtract. So we have 9a minus 4a is 5a, 3b minus 2b is 1b or b, and then 17 minus 10 is just 7. So our answer would be 5a plus b is equal to 7. Mark it as our equation number 5. Next one would be the last elimination method that we will do. So that is to eliminate b to solve for a. And we are going to subtract the equations that were obtained earlier, equation 5 minus equation 4. So I'll write equation 5 down. Equation 5 is 5a plus b equals 7. And equation 4 is 3a plus b is equal to 5. So subtract the two equations. The variable that will be eliminated here is b, since b minus b is 0. So subtract the rest. We have 5a minus 3a is 2a. 7 minus 5 is equal to 2. And then, to solve for a, divide both sides by 2. So 2a divided by 2 is a, and 2 divided by 2 is 1. So our value of a is equal to 1. And next, we're going to solve for b and c. Okay? So, unahin muna natin si b. We will choose from equation 4 or 5. So from this particular example, we are going to use equation number 4. And that is 3a plus b is equal to 5. The one that we have solved earlier, which is the value of a, which is 1, yun yung gagamitin natin for this equation number 4. Okay? So we have substitute 1 for a. So we have 3 times 1 plus b is equal to 5. 3 times 1 is 3. So we have it there, and then simplify lang. 3 plus b is equal to 5. So b is equal to 5 minus 3. 5 minus 3 is 2. So the value of b is equal to 2. Now that we have the values for a and b, we are going to choose from equation 1 to equation 3 to solve for the last variable, which is variable c. Okay, so for this particular example, I am using equation 1. So we have a plus b plus c is equal to 5. Our value of a is 1, so substitute 1. Our value of b is 2, so substitute 2. So we have 1 plus 2 plus c is equal to 5. 1 plus 2 is 3. So we have 3 plus c is equal to 5. And then just solve for c, transpose c to the other side of the equation. So we have, transpose 3 to the other side of the equation. So it is 5 minus 3. And 5 minus 3 is just 2. So the three values that we have for the three variables are 1, 2, and 2. So from the general rule, we'll go back to the main general rule of quadratic equation. So it is an is equal to an squared plus bn plus c. Substitute an is equal to an squared plus bn plus c. So here our a is 1, our b is 2, our c is 2. So for us to simplify it, we'll have 1n squared plus 2n plus 2. 1 times n squared is just n squared. So our final answer would be a sub n is equal to n squared plus 2n plus 2.